Most of us treat AI like a vending machine. You drop in a prompt, and a single response pops out. That single execution is an atom. It is undeniably useful on its own, but an isolated atom is strictly limited in what it can actually build. Real production work doesn't function like that. Real work is molecular. It requires overlapping tasks that depend on each other, loop back to fix errors, and branch out conditionally. Think about the process required to ship one software feature. You have to understand the requirements, plan the architecture, write the code, run the tests, fix the failures, and review the changes. A single AI agent trying to execute all of those steps will eventually collapse under the weight of the project. It cannot hold all the necessary context in its memory at once, and it certainly can't instantly switch between being a broad-thinking researcher and a highly specialized code reviewer midstream. Workflow orchestration solves this by engineering an automated assembly line where the focus shifts from receiving a single response to managing a sequence of interconnected, high-leverage tasks. Take a look at this loop. It maps out a primitive form of orchestration modeled after a technique Jeffrey Huntley calls the Ralph Wiggum loop. It's a basic bash script that feeds a prompt to an AI, reads the result, and loops it continuously. Using that exact cycle, Huntley completed a $50,000 freelance contract for exactly $297 in API costs. The mechanical logic here is straightforward. The agent checks the current state of the code, compares it to the desired goal, and does the work to close the gap. It just repeats that action with constant feedback, shaving down the difference until the job is complete. While this is a functional minimum viable workflow, its success relies entirely on the raw capacity of a single agent to figure everything out on the fly. At an enterprise scale, throwing a single agent into an infinite loop is a liability. To build something reliable, those simple loops have to evolve into structured pipelines with strictly separated roles. This hierarchy graph maps out a native's workflow engine, which enforces a strict separation between planning and execution. At the top, the planner profile handles broad reasoning and strategy. It has deep context on the project, but zero permissions to actually write or change code. Below it, the executors take over. These agents act with precision, armed with highly narrow write permissions to carry out the planner's exact instructions. Separating those roles is critical, but enterprise systems like Stripe's toolshed rely on an additional architectural layer, mixing unpredictable AI with hard-coded logic. This pipeline illustrates how that works. It alternates evenly between agentic nodes, which handle probabilistic, creative reasoning, and deterministic nodes, which are rigid scripts that run APIs and verify data. This structure acts as a ratchet. The creative, unpredictable AI outputs are forced through unforgiving, deterministic quality gates. The system cannot move forward until those hard-coded verifications pass. By orchestrating strategic planning, precise execution, and rigid verification, you strip away the unpredictability of language models. The result is a highly reliable production engine. You can see exactly how this engine maps tasks in real time by clicking the link in the description to visit anative.business. Every complex business process you can imagine eventually deconstructs into just 6 core orchestration patterns. We start with 3 foundational models: the sequence, running steps linearly; the planner-executor, breaking strategy down into specific tasks; and the checkpoint, which halts the workflow for explicit human approval. Then we add the iterative patterns: the loop for continuous refinement, parallel to run independent tasks simultaneously, and the swarm, where a cluster of specialized agents attacks the same problem from different angles. These aren't isolated templates. They are composable building blocks. You can snap together a planner-executor workflow that triggers parallel steps and then runs them through a checkpoint. When you master these composable patterns, you have the mechanics to automate any arbitrary workflow, regardless of scale. This architecture is forming the application layer of a rapidly maturing ecosystem. It sits right on top of back-end frameworks, like Temporal for durable execution, LangGraph for agent memory, and A2A protocols for cross-agent communication. In this environment, a single AI agent provides the raw labor, while the orchestrated blueprint provides the industrial logic, making that labor scalable. This marks a transition towards self-building systems, where engineering efforts are focused on the machine that does the work. If this breakdown helped you understand orchestration, like the video and subscribe for more explorations into production-grade AI.